Hi everyone, I am Mohit, a graduate student of the Maranas group at Penn State University. In the last video, we explained novoStoic 2.0 and how it integrates four different tools into a unified pathway design platform to construct biosynthetic pathways for target molecules. In this video, we'll walk through the web interface of novoStoic 2.0 developed by the NCSA team at MMLI. We will look at an example starting from initial user input to final pathways in this video. As you can see in the workflow, pathway design starts by determining the overall stoichiometry using the optStoic tool. This overall reaction is then passed to the pathway search module using novoStoic 1.0 that designs potential pathways. At the same time, DG Predictor evaluates the thermodynamic feasibility of the enzymatic reactions within those pathways, and EnzRank. It helps identify suitable enzyme candidates for any novel reactions predicted in the pathway. Let's start with optStoic. To begin, the user needs to provide both a starting molecule and a target molecule. You can enter the molecule information using various identifiers such as the name, SMILES, INCHI, KEG ID, or Metanetics ID for both the starting and the target molecules. In future updates, we plan to add more flexibility to the inputs. For example, you will be able to specify co-reactants or ATP molecules, which will help generate additional solutions for the overall stoichiometry from optStoic. Here, I'm going to use L-tyrosine. And once I click below the input, the fields, the molecule structure appears, confirming that the inputs are validated. Similarly, for the target molecule, I'll input hydroxytyrosol. Again, the molecule is validated, and I can input my email here to get email notification when the results are ready, and click Get Overall Stoichiometry. The optStoic tool typically takes about 5 minutes to run and return a solution, but for this video, I'll jump straight to the results. In the results, you will see the primary precursor represented by a green dot and the primary product represented by a blue dot. optStoic automatically adds co-reactants and co-products from a predefined list of cofactors and small molecules to ensure elemental and charge balance in the overall reaction. For each overall stoichiometry identified, it also displays the estimated Gibbs free energy of the overall reaction along with the theoretical yield of the target molecule. Now, each of these overall stoichiometries can be used as a starting point for pathway design. However, it's important to note that not every stoichiometry will necessarily lead to a viable pathway solution. That's why generating multiple stoichiometries is beneficial. In this example, optStoic generates 17 different solutions, And as I mentioned earlier, once we introduce more flexible input options in future updates, we will be able to generate even more stoichiometries. For now, I'll move forward by selecting one of these solutions and click Pathway Design. Once we do that, we can play around with the settings, like the maximum number of reaction steps per pathway design, the maximum number of pathways generated, and the number of enzyme candidates to be displayed for each novel step. Again, I can input my email and click Pathway Search. Without waiting for the results, I'll jump into show you what this job actually gives as the results. So for this selected stoichiometry, you will see that there are 7 pathways found, each with either 3 or 4 steps. When you hover over any molecule in the pathway, it will show additional details such as KEGG IDs and SMILE strings. By clicking over a specific pathway, you can view comprehensive details for each reaction. This includes co-reactants and co-products, the estimated Gibbs free energy for each step, and the enzyme candidates identified for any novel reaction in the pathway. If the user wants to explore an overall stoichiometry that was not included in the results of optStoic, then they have the option to run a pathway search job manually. We click on Run a New Request and we get to this page. And for this demonstration, I am going to input a different overall stoichiometry for the same starting and target molecule, L-tyrosine and hydroxytyrosol. To do that, I will first enter the primary reactant and its amount. Followed by all the co-reactants and their amounts. Followed by all the co-products and their amounts. And finally, the target molecule and its amount. This particular stoichiometry comes from an existing pathway from the literature, and we want to see whether novoStoic 2.0 can reproduce an existing pathway or find a shorter one that is a more efficient pathway. Again, we can play around with the settings and click Pathway Search. Without waiting for the results, I can again show you what we got. These pathways show 3-step solutions, and we have 6 different pathway solutions. Here, novoStoic found shorter pathway than the existing one. Finally, I want to show DG Predictor and EnzRank as standalone tools. As I mentioned earlier, DG Predictor estimates the Gibbs free energy of any enzymatic reaction. If we use the example, we see that we can input KEGG IDs, and if a molecule is not present in the KEGG database, we can input a hypothetical ID along with the inchy string or the smile strings of that molecule. We can simultaneously add 5 different reactions to calculate the Gibbs free energy. And pH 7 and ionic strength 0.1 are the default settings to calculate Gibbs free energy using DG Predictor. Let's click calculate Gibbs free energy, and the pre-computed results will appear for this example. Again, for EnzRank, given a primary precursor and an enzyme candidate, we can find compatibility score for a novel reaction. So using an example, we can click calculate activity score, and a pre-computed result will appear. So for a given reaction, the primary precursor and the enzyme candidate has an activity score of 0.805. So what EnzRank can do is take in multiple enzyme candidates and calculate the activity score, finally rank ordering them in the descending order. This is how EnzRank chooses the best enzyme candidates for any given novel reaction in pathway search. That's it for all the tools here. Thank you for watching the video.